excited to get to do this. I was planning to do this today anyway, and then unfortunately Mr. Stark wasn't feeling well, so I just decided I'd come in anyway. So today what we're going to talk about are what square roots really are, and then how we can find square roots if they're imperfect. Like, how do I find the square root of 11? Because that's not a perfect square, right? Okay, so tell me, what is a square root? Somebody. Yes? Okay, so you would find the square root of a number to a second power. So a square, to square a number, is number to a second power, or that number times that number, right? So what does the square root ask me to do? What does it ask me to do? What do I have to find? A number that can be multiplied by what? By 2? By itself. So a number multiplied by itself to get that number. So a square of a number and the square root are inverse operations. Okay, so just like addition undoes subtraction, subtraction undoes addition. If I have the square root of x and I need to do the inverse of it, I would just square it. Okay, I multiply it by the square root of x, right? So I'd square it, and the square root of x times the square root of x is x. Okay? So those are inverse operations. So, and now let's look and see if I have a square and my side length is x, how do I find the area of that square? Base times height, or length times width. But in a square, all sides are the same, right? Yeah. So it's side times side, or how could I write that? Side what? Squared. Squared. Side squared. Okay? So you can find that by side squared. Okay? And that's going to give you your area. Because I'm taking length times width, or base times height, or however we want to look at it, or side times side, and they're the same, so all I'm doing is squaring that number to get the area. So let me hand you this, and I think I probably have enough between all the little things. Pass those down. I might actually have enough little baggies that everybody gets their own bunch of squares. You might have to share a little. You don't need that many, but it's good just to have some to be able to use. That's the most encouraging. Maybe you guys can share that back. So, create a square. Create the smallest square you can create. A regular square. Yeah, this is create a square. Okay? Here you go. You can combine those two bags. Okay. So what's the smallest square I can create? A 1 by 1, right? Yes. Yep. Perfect. Okay, so let's look. Now, I may or may not, depending on how, like, you guys are small, and you guys seem pretty well behaved and quiet. I might be able to get to the cubes, but if I don't, it's on the back, and we'll talk about that in a second. Let's do 3. Yes, sir.
What else did you already do?
You were already in Miss Rose class? You can help me out. Okay. Are you recording as well? Yeah, I am recording it just because Miss Broussard wanted me to show how this was done. And so no, she can't hear it now. She will. I'm not sure. She can look through it. It's more for her about me than it is about you. So don't be all nervous. Okay. Yes, that's your sheet. Make sure you're on the side that doesn't say cube, but it says square. Okay. So. Okay. So if we've seen this, some people have seen this, and I apologize, but I think it's good to see. All right? So when they decided to find square roots of a number, they didn't just arbitrarily decide, you know, I think I'm going to make this up and I'm going to call it a square root. Okay, they actually have a reason. Okay, it relates to the area of a square. Okay, so when they ask you to find the square root, they're asking you for a specific part of that square. So on the first one, this is my visual model. Okay, it's 1 square. That's the smallest square you can make with those, right? So what is the area of that? 1, right? 1 square unit. And isn't area always written as a square? Right? A square unit. Because it's 2D. It's 2-dimensional. So you can always think about this. This is units squared. Well, that's 2-dimensional. So that's why it has a square on it. Cubes, okay, or volume is a 3-dimensional object, and your units are always going to be cubed. Okay, so that's just one of the things that I try to remember so I can remember what kind of units go into it, okay? So then what is the length of the side of the square? 1. So the square root of 1 is 1. Okay, well this one's a little tricky so because it doesn't, you kind of keep seeing the same number and you can't differentiate the others. So let's try and make another perfect square. What's the next square I can make with those? 4. Okay, so it would look like this, right? Okay, so what is the area of that? 4. So 4 units squared. All right, like that. What's the side length? 2. Oh. Right? No matter which side I look at. 2, 2, 2, 2, right? And this is just units. Right? So length is just the unit. Area is squared. And volume is cubed. All right, so now, if I go over here, I'm looking to find the square root of 4. And what is the square root of 4? 2. Now, what does that 4 relate to on that table?
The side square.
They're obviously the area. That's what I was looking for. So this 4 represents the area. And this 2 represents the side length. Do you think that what kind of relationship are you seeing? Let's try one more and see if you can see it. And then we'll go through. Okay, so the next biggest one would be what? Can I make it 3 by 3? I can't make a perfect square with 8, right? So 3 by 3. So what's my area? 9 units squared. What's my side length? 3 units. And so the square root of 9 is 3. So are you seeing a relationship? What am I taking the square root of? The what? She said it. The area. I'm taking the square root of the area, and I'm finding the what? Then what's it giving me?
Unit.
Side length. Okay? So this wonderful relationship is that the square root of the area of the square gives me the side length. Okay? So this is how they're related. All right, it's not just that they decided they wanted to make up these numbers and say, "Oh, good, this is going to really confuse people. I'm going to put this funky looking symbol, and I'm going to confuse them to death." No, there's a reason. Okay, so the square root of the area, and write that down. Square root of the area equals the side length. Okay, so what would be the area of the next one? 16 units squared. What would be my side length? 4 units. So the square root of 16 is 4. Okay, what about the next one? 25 would be my area. And my side length would be 5. So what if I wanted to go backwards? What if I said I have a side length of 2? What is the square? 4. So I'd go backwards, right? I'd take the square of the side length to get the area, and that's what we talked about at the beginning. To find the square of the side length to give you the area, and the square root, see, we're undoing them. See how I went one way and then I went backwards? So if I square this, I get this. If I square root this, I get this. Okay, so that's how they're related. All right, so 3 squared gives 9. Square root of 9 gives 3. Same thing. Okay? So what I want to go through is I want to talk about how we estimate. Were you in first period or second period? Okay, so you did get to this a little bit. All right, so in the square roots, we're estimating these because what are perfect squares? Right, and it gives you a what kind of number? Or a negative. But it's a what? Is it a fraction? Is it a decimal? It's a whole number, right? So perfect squares are whole numbers. All right? All right. So now, on this paper that has the grid paper, I'm going to show you a trick. Again, I'm going to show you that mathematicians didn't just decide one day to try to totally confuse people, okay? So I want you to start, and I want you to create your perfect square table on here, okay, so you can actually visually see it. So if I start out and I do my square, here's one, right? What's the area of that square? One. What's the side length? One. Okay, so now I go to the next one. Again, I have to make a square. So I extend one direction, one square in all directions. So now what's my side length? Two. And now what's my area? 4. Right? How many squares are there? 3 plus that one, because I have to include that one, right? I want that whole square. So if you're building this on your table, you could fold it out and look like this. So you have your red square. And then I go and I make the next biggest one. Okay? Now I know you probably can't see it. You can try to see it, but so then I build my next one, right? And then I build the next one, and the next one. And so I could pull this out, and you could see that I have to include that red square, or that first square, to make it a perfect square, right? It's not a square if I take this one out. It's just some weird, funky angle shape. Okay? So what about the next one I could make? I make it go one more. Okay? Adding 5 to it, but so 4 plus 5 is how many? 9. Okay? So my area is what? 9, and my side length is 3. Okay? So all we're doing is we're now just kind of showing this as another way. Before, when we had it, we were drawing them out in our little squares. Now we're just drawing it on a grid paper. So I'm going to show you a trick here that you can use this, and then how you can make it go to mathematically. So then let's go bigger. What's the next one? What's the next perfect square? 16. So if I add 1, 2, 3, 4, 5, 6, 7 to 9, do I get 16? Okay. So there's 16. You guys are like a breath of fresh air. You guys are awesome. If I had scholar, I got apply for $100. Or we'll say note to self. We give you a $100. You guys are awesome. Okay. So then the next one. 25. So there. I'm going to go to like 36. Okay. So my side length is what? 5. And my area is what? 25. This next one would be what? 6 and 36. 7 and 49. 8 and 64. 9 and 81. Okay? So this would be 36. Trying to find different colors. This would be 49. I know some of you are like, yeah, okay, they're just big squares, right? So I'm going to show a trick about trying to find those odd square roots. Okay, because if I say, what is the square root of 9? You can tell me it's what? 3, right? Because 9 squares can be put into a square that has a square of 3 by 3. So 9 little squares, okay, can be put into to make it 3 by 3. All right, but what if I say, so make your, so take out your squares and take 11 squares. You have 11 squares. Can you make a square with 11 squares? Okay, so I need to find what is the square root of 11 because I want to only have an area of 11. So I have to figure out, so think about it. So maybe I have a piece of carpet and it's 11 square feet, okay? But I need to figure out what side length I need to make the size of my square. Like say I want to build like a frame around this carpet. Okay, I got to figure out what side lengths I have to cover that 11 square feet. All right. So if I'm looking, so if you put together your 11 squares, figure out the best that you can. Try and make it in the best square that you can. No, 6. So that's too bad. So how many do you have left over? All right, out of making your square. So you've made a square, and you had how many left over? 2, right? Okay, so let's look then on this table. What was the side length of this actual square you were able to do? 3. So you were able to find 9, right? So if I look at the square root of 11, it falls between 9 and 16, right?
Yes.
So if I'm going to put this on a number line, it's going to fall between what number and what number? Is it 9 and 16, or is it, what's the square root of 9?
Root of 9.
It is 3. And the square root of 16 is? 4. So that number is going to fall somewhere between 3 and 4. Okay, so if I put it into the calculator, it's going to be 3 point something something. Okay? And we said that, so your 3 is your whole number, and you said you had 2 left over, right? So if I have 2 left over, out of how many would I need to make the square get a perfect square? If I have this many, and I use up this one and this one, how many more do I need to make it to be a real square?
Oh.
I need a total of 7 to go from this one to this one, right? You've done this before. You weren't in Mr. O's class, were you? I didn't. Huh? Were you in there when I did it? Oh. Oh, okay. So she's teaching you these things. Awesome. So you guys have got this. You guys have got these imperfect squares. Okay, so I know it's going to be a 3 of a whole number. And then, so I'm just looking and I'll show you where we get to the mathematics because you've already got it to where we're doing the subtraction. I'm doing just visual. I've got 2 out of how many more? 1, 2, 3, 4, 5, 6, 7. 2 out of 7. So if I take 2 divided by 7, who's got a phone that they can do 2 out of 7 real quick? I don't know. She has there's calculator. She told me where they were and I forgot. 2 divided by 7. Okay, so 0.2857. Okay, 0.2857. Or I'll just say 3.286. Okay, I'll just estimate. So now let's look and say what happens if I put the square root of 11. So I put 11 and I put the square root symbol. Oh, square root. I don't remember how to use these. So when I put this in, I get 3.316. Okay, so this is my estimate, and this is the calculation. Okay? Are those close? If I had to put them on a number line, could you think I'd probably guess about, or I'd be able to figure out about the right area?
Yes.
Okay, so 3.3, I'd say about here. So let's say 3.3 or the square root of 11. Okay? So let's try and see. What if I have somebody else give me a number? Give me a number that's not a perfect square.
2. No, it's 5.
23? Okay, so the square root of 23. try some on the back. And then I want to see if you guys can make that connection to that mathematical equation she was saying. So when you said 23. So I say the square root of 23. Try that. See if you can figure out without putting it in your calculator. He's like, I got this. I point. Okay. Okay. So I got a 4.7. You got a 4.7. What else do we get? Anybody have it as a fraction? Wait, 4, and then what's the fraction?
7. No. Oh, 1.
What'd you get? Sweetie, what'd you get? Share your hand up. What's your name? I'm sorry.
This one, but I'm confused.
Okay, so I'm looking for the square root of 23. So again, I've got 23 squares, and I'm trying to make them into a square. I can't do that, right? What is the biggest square I can make with those 23 squares? I can't go to 25. I'm too short. So what's the next one down? 16. Okay? So I know that I can make this. This is my square, right? I've got 16. So I know it's going to be greater than 4, right? Because that whole 4 fits in there. So then I say 16, 17, 18, 19, 20, 21, 22, 23. Okay? So this is what my square looks like. That's kind of funky looking, right? That's not really a square. So how many extras did I have? 7. How many extras do I need to get to the next perfect square? 2 plus that 7, which is 9. Okay? So if I take 7 divided by 9, what do I get? 7 divided by 9? Okay. So 4.7 repeated. Okay? So now let's go and let's look. What happens if I put 23 in my calculator and hit the square root button? I get, here's my estimate, and I get 4.79. Pretty close, right? Okay? So we were able to use our perfect squares to find our imperfect squares. All right? So if I had to put this on a number line, it'd fall between what number and what number? 4 and 5. Okay, no, you're the square root of 16 and the square root of 25. So again, if you see this, and I can't remember if I said this in this class or the other class, but if you see in an equation x squared plus the square root of 16, don't freak out and go, oh my God, what rule am I supposed to use for square roots? Okay, how do I do it? No, what is the square root of 16? 4. They are going to show you different representations of whole numbers to make sure you really understand. So they'll throw in square root of 25, square root of 36. All that means is it's 6. Okay, you don't have to go, oh, panic, oh no, I'm supposed to, what do I do when the square root, okay, if the things are the same, I do this, if they're different, no, it's a perfect square. Okay, so the square root of 16 can also be written as 4, square root of 25 can also be written as 5. So it's going to be somewhere about 3/4 of the way, right? So that'd be the square root of 23. All right, so what's your name, sweetheart? Amaya. Okay, so you said there was some way that I could do it and I could do subtraction. Okay, so let's look. Oh, wait, here, hold on. Let me keep that. All right, so let's look at it and try our subtraction. So if I look here, if I have this and then I have y and z. Okay, so this is how I'd write it, right? So what does my x represent? The whole number or the what? The perfect number. Perfect number. The smallest perfect square that fits in. Perfect square that fits. Okay, so it's the smallest. Or wait, I'm sorry, the largest perfect square that fits in. The largest perfect square that fits into that number. So like when I said 23, the largest square I could make was 16, which is 4. Okay, so that's my whole number. So there I got my 4. Now, I ended up with 7 over 9. How could I figure that out? Mathematically. Okay, well that's how I get what that is as a decimal. How could I get 7 and how could I get 9?
Isn't it 49?
Subtract, right? Okay. So the top one, what do I use? What numbers do I use?
23 and
So I would do 23 and 16 minus 16. Okay, and that'd give me 7. But what does that 23 represent? That's my imperfect square. Or imperfect square. Minus, so let me write that bigger. So that's my imperfect square minus the perfect square. Okay? So that was that 25 or 23 minus 16. Because I've taken this out. So just like in fractions, when I get the whole, I take it out and I move it over and I make it the whole and then whatever's left. That's exactly what I'm doing. Okay? Because essentially you could say that this is 23 over, no, I'm sorry. I'm trying to say that wrong. But you could make it like an improper fraction, which would get you to 4 and 7 ninths. All right. So then what would the bottom be? 9. How did I get 9? So 25 minus 16. So what did I do there? Okay, so I'm just going to write it up here so I have room. Subtract the largest, or the next, I'm going to say next perfect square. Next perfect square minus the lower perfect square. I'll rewrite this on another slide so you can actually see without all this extra stuff. Okay, so let's go here. If I go and I want to say the square root of 17, okay? What is the perfect square that fits into 17? Sorry, give you the answer. 16, which is 4. Okay? So there's my whole number, right? So now, if it falls between, so this falls between the square root of 16 and the square root of 25, right? So it falls between 4 and 5, okay? So it's greater than 4, so I know the whole number is 4. How many greater than 4 is it? 1. So how could I find that? No, not divide. We said it was subtraction. So I would subtract what? 17 minus 16, right? And then what would I do on the bottom one? 25 minus 16. Okay? So that's 1 over 9, right? So 4 and 1, 9. So let's see. 4 and 1 ninth. Yeah, 0.1. Okay, so then if I take the square root of 17, it should be about 4.1, and it's 4.123. Okay, so let's try one more. We'll try it using the subtraction. So if I have the square root of 28, okay, I know it falls between what and what? Square root of 25 and the square root of 36. Okay, because it's greater than 25, but it's less than 36. So I'm figuring out where does it fall on that number line. Square root of 25 is really what? 5. The square root of 36 is really what? 6. Okay, so I could take away and figure out how many extra, because what I'm doing is I'm trying to figure out how many blocks do I have extra after I take that perfect square out. So if I take, so I know that I have 5. Okay, so I've taken how many blocks out?
3. Never mind.
If I have 5 squared, how many blocks does that give me? If I'm making my square on the table. 28 minus 25. Okay, because I know that I have 28. That's what I'm looking for. Minus the 25, and that tells me how many extra squares. Okay, so this gives me Now, the bottom part is how many squares it is between the perfect squares. Okay, so this is your distance between perfect squares. 36 minus 25. Okay, so what's 28 minus 25? 3. So that's 5 and 3 over
11.
11. Okay, so if I sat and I did that out with my squares, I would see that I had 3 extra squares to go into my next box, and I need a whole 11 to make that box. Okay, so like if I went back over here, oh yeah, there it is. Okay, so if I went back over here and I looked at, okay, and I looked at, what was that number? What did I use? 27? What number did I use? 28. Okay, so I know that it's going to take up all this right here, right? This is the box that I'm making. So all of these squares are in here. So I have 25, 26, 27, and 28. So that's a funky looking box, right? That's not a perfect square. It's going to be some sort of a decimal. So I need to figure out then, what do I need to do to get to the whole, to get to the next perfect square, right? And how many do I have already to get to that next perfect square?
3.
So I have 3 out of
8 out of 8.
well, 8 left, 9, 10, 11. So I have to add those back in because it's that fraction. Okay, the whole is all of it combined. So this is kind of both colors. Okay? Does that help? Make sense? Okay, so flip it over for a second. And look at the square root of 4. What time y'all get out of here? 16, 17, something like that? What time should I let you go?
Like 222.
222? Got it. Okay, so flip it over. Try and figure out the square root of 42. Now with the calculator. Oh, man.
42.
Square root of 42. Yeah, give me a pass real quick.
No, I know you said it.
You said the square root of 42.
Oh, we didn't give you guys for color. I'm sorry.
It's 7.
So, and keep this, because I don't want her coming back on. What y'all do when you guys go, I don't know. Okay? You got to be able to tell her how you did it. So tomorrow when she comes in and goes, hey, what'd you do? You'll just explain it. Okay? You got this. You tell me how to subtract it and do all that stuff. All right? So, square root of 42. Figure out where it falls. Okay? Try it on your paper real quick. I want everybody to have it. Come on. Square root of 42. Square root of 42. Try it. And if you can go ahead and start putting your little tiles into the bags, that'd be great. 36? 49. Okay. Okay, so let's go back over here. Got the square root of 42. Whoa, I don't think that. Square root of 42. Right. Now there's simplifying and there's estimating. Simplifying is when have you guys done that yet? Where you take and you do like the tree, like the factor tree?
Oh, yeah. It's like a family tree.
Okay, yeah, kind of. So some people may have seen that, some people haven't. That's different. We're estimating. We're trying to figure out where it is. We're not trying to simplify, we're trying to estimate it. Okay? So, square root of 42. We know that falls between what two perfect squares?
Wait.
36 at 7.
36, 49. Okay. It's going to be closer to 36, but I can actually figure out what it's going to be, right? So, it's going to be, so in 36, square root of 36 is really what? 6. And square root of 49 is really 7. Okay? So, it falls, I'm just going to write it in here somewhere, okay? I'm just going to put it in here, 42. All right. So now, what is my whole number? Yes, you do. What's my whole number?
Yes. 6.
6. My whole number is 6. Okay? So now, what is the distance between, okay, distance between imperfect and perfect and lower perfect? And then, give me one second. Distance between, when she gets back, to perfect. Okay. So, if I want to figure out the distance between the imperfect and the lower perfect, what do I subtract?
You subtract the whole number.
Okay, which ones? What numbers?
42 minus 36.
42 minus 36. Did you get that?
That's the numerator.
42. Awesome. Minus 36. She even used the math terms. There's your numerator. 42 minus 36. And the other one's going to be what? Minus 36. Because this is the distance between what I'm looking for and the perfect square. And this is the distance between the two perfect squares. So I get 6 and 36, 42.
Wait, I got it.
Okay, you tell me. 36, 37, 38, 39, 40 for 1, for 2. Yeah, I'm not above using my fingers. I teach math and I'm not above using my fingers. Okay, 49 minus 36. Well, I know 4 minus 3 is 1. 9 minus
16. I mean, 13.
13. So 6 13ths. Now, I'm not even going to lie. I can't do 6 13ths in my head without really sitting down and trying to think about it. So I'm going to use the calculator. And I'm going to say, what is 6 divided by 13? 0.46. Okay? So this as a decimal, 0.46. So my number would be, what? 6.46. So it would actually be closer to where I made this arrow here because it'd be right there about in the middle. Okay, I thought it'd be closer this way. Not really. Okay, it's right there in that middle. Okay? Does this help? You guys kind of see this?
You
totally lost me. Okay, I'm going to give you guys a few seconds to try one more problem. Try number 5, and I'm going to come and help. Do number 5 for me. Okay. What perfect square? I have it. It's not perfect, but what's the one next to it? 16 and 5 squared is what? So positive squared is 16. So I know it's got to be less than 5, so the whole number's not 5. The whole number's what? The square root of 16, which is so it's 4. So I know that. So now 21 is what I'm asking. And what's the and how many more is that? Take the subtraction. So if I did 21 minus no, you're fine. Yeah, it is. Sorry. Okay. So 5. Now, that's gonna be a fraction over. Now, this is the whole number, so don't put the full 5 over. So now, 16 and 25. Because now we know it falls between 16 and 25. What's the difference between 16 and 25? Okay, by how many? Okay, so yes, and 75 over the 4 and 5 would be 4. And that's what's in. If I put that in a decimal, that would be what it is. Whatever 5 9 is what it is. So and then if you put that in 5 2, you just get that out? Okay. It's 222. Okay, please take your blocks, your little whatever we call these tiles, and put them in their baggies. Please try not to leave any on the floor. Like our math department needs every little bit of materials. So find them on the floor, stick them in your baggie. I don't care if they're in the same baggie they came in. Put them in the baggie and stick them on the table. keep your paper. Oh, wait. Hold on. I'm supposed to give you homework. She'll get mad at me.
Yeah, you're right,
Oh,
right.
sorry. I'm
Right.
sorry. Just know what I'm told. There you go. Sorry. It's only like 6 questions. Don't hate me. All right, here you go. Thank you. So, did it help? Yes? No? Maybe so? A little bit? I think the more you see it, did it help you a little bit? Okay, good. Thank you. You're welcome. Here you go. Don't forget that. Did that help you a little bit? Okay, good. 'Cause I'll tell you, I haven't taught this, and I did not learn this until last year. And I was like, oh my God, this helps so much because